Alright, a little bit more here about fatty acids. I have a couple of fatty acids drawn out here for you. Starting with this one down here at the bottom. This is a 20 carbon, which this would be a long chain fatty acid. Carbon number 1 here at the carboxyl group, which is carbon double bonded to an oxygen and single bonded to the hydroxyl group. So that's your carboxyl. That's what makes this an acid. The fatty part again is the long chain of 19 more carbons, and you'll notice there are no double bonds here. So this is a saturated fatty acid. The 20 carbon saturated fatty acid is called arachidic acid, coming from a Latin word meaning peanut. All right, now up here we also have a 20 carbon fatty acid, but this one has 1, 2, 3, 4 cis double bonds in it. Now we know that they are cis from the angle that they're drawn at, and what that implies is that there are hydrogens in these locations. The hydrogens are always on the same side of the double bond. And what that does, by having 4 double bonds in it, that can be called 4 degrees of unsaturation. And since they are all of the cis orientation, you'll notice that that causes this 20 carbon fatty acid to curl around, and it is more restricted in its shape. We could say, you might hear it said that the saturated version down here has more degrees of freedom. But also you can see that it can kind of just make a long zigzag chain that's relatively straight. Now when you start trying to stack these things together, because this is a long straight chain, you can stack these side by side more easily. Kind of like playing Tetris. You know, when you get that piece that's like this versus the piece that's like this, these are much more easy to stack together than the T-shaped ones. So these long straight chains, they will stack together and get closer. And of course, that's one of the things that has to occur when something solidifies. Its molecules need to slow down and get very close to each other. So saturated fats tend to be solids because their saturated fatty acid chains can pack together much more neatly than these polyunsaturated, and there's a term I didn't use and meant to, with multiple double bonds, multiple degrees of unsaturation. This is a polyunsaturated fatty acid. This one's name is arachidonic acid. It is very important in biology. Arachidonic acid is used in the formation of type of hormone known as prostaglandins, and also things called leukotrienes. And get a little too far off into biology here, I guess. Whoops, leukotrienes. Leukotrienes associated with things like asthma. Prostaglandins are, technically they are not a hormone because they are not distributed through the body in the bloodstream. They do the same type of signaling job that hormones do, but they only work locally, just in body fluids right around the cells that secrete them. But those things, prostaglandins and leukotrienes, are made from arachidonic acid. Alright, so what have we seen here today? We've seen polyunsaturated. This arachidonic acid is an example of a polyunsaturated fatty acid. and both arachidic and arachidonic acid are long chain fatty acids. We talked earlier about medium chain fatty acids making up medium chain triglycerides. So that's going to be it for this segment, and see you on the next one.